So here we're given a list of equations and we're asked to solve for x. The first one is 5x minus 7 is 28. I'm going to isolate the terms with x, add 7 to both sides, and that becomes 35. So 5x is 35. To isolate x, I divide both sides by 5, and x is 7. B is 12 minus 5x equal to x plus 30. I'm going to add 5x to both sides. The reason is I like to have the coefficient of the unknowns positive. So even though I could subtract x, I chose to do 5x. And then I would subtract 30 from both sides because I want to isolate 6x here. So that would be 6x is 12 minus 30, which is minus 18. And then to isolate x, I divide by 6, which is minus 3. Then C is 5 times x plus 2 equal to 1 minus 3x. I'm going to distribute this here. Becomes 5x plus 10. And then I'm going to combine like terms, add 3x to both sides. This side becomes 8x. And then subtract 10 from both sides. I get 8x is 1 minus 10, which is minus 9. And so we're left with 8x equal to minus n. To isolate x, I divide both sides by 8. I get minus 9 over 8. D is x plus 6 times 2x minus 1 equal to 0. So here, we don't want to do the, it's not a good idea to do the distribution because you just end up with quadratic, and you would have to come back here. So this has already been factored to you, and you can think of this as product of two numbers, a times b is 0, and that would be true when either piece is 0. So if I force x plus 6 to be equal to 0, which means x could be minus 6, or 2x minus 1 is 0, which is equivalent to x is equal to half. So those are the two possible values of x that satisfy this equation. And then E is x squared plus 5x minus 14 equal to 0. And here I'm going to write it as x. I need to get 14, so I know 7 and 2, and their difference is 5, and then I have to decide where to put the sign. So this would be plus 7 minus, and we can check if you distribute x squared minus 2x plus 7x minus 14, and that is indeed the same as the original quadratic. So here, this would be true when x is either minus 7 or x is equal to 2. The final is the x squared minus x minus 1 equals 0. And you'll notice that if you try to factor it, this one is difficult to factor because these numbers here on both sides of x, they have to have radicals. So this one requires you to use the quadratic formula, which for a general quadratic is minus b plus minus square root of b squared minus 4ac over 2a. Now, I have to say that I haven't so far seen on the GRE where I was forced to use the quadratic formula to solve for the roots or the solutions of this quadratic. So I haven't seen it personally, but the fact that they have this problem here in the practice set means that they do expect you to know and be able to apply it. So what you have to do is to identify what a is. A is 1. B is minus 1. It includes the sign. And then C is also equal to minus 1. And then we replace those values here. So minus of minus 1 and minus 1 square minus 4. A is 1. C is minus 1 over 2a, which a is 1. So minus of minus 1 is 1 plus minus. We're going to have two values. And this is just 1. And because we have a minus here and a minus, it becomes 1 plus 4 over 2. This is same as 1 plus minus root 5 over 2. So the two values of x here are 1 plus root 5 over 2, and the other one is 1 minus root 5 over 2. And that's why to factor this, it's nearly impossible for someone to come up with these numbers. So that's why we had to use the quadratic formula.